Hello, today we're going to look at the step question from assignment 6. If you haven't yet looked at all of the assignments, there is some work about conditional probabilities and the probability that if you get a positive test result, what's the probability that you actually have the disease that you've tested for. There's a lot about arrangements in this assignment, and the step question is all about arrangements. Right at the end of the assignment, there's some examples. So if you haven't met arrangements before, it's a good idea to work through those examples first before having a look at the rest of the question. So let's have a look at what the step question says. So the step question is in two parts. There's a part I and an II, and there's an example at the start. So 47231 is a 5-digit number whose digit sum is 17. So to tell you what a digit sum is. Okay, so we'll start by looking at part I. So part I is talking about a 5-digit number whose digits sum to 43. So if you think about these digit sums, then the largest digit sum we can get with a 5-digit number is 99999, which sums to 45. So that's obviously too big. And if we tried 999998, that would sum to 44. So we can see from this, if we have 99997, that will add up to give you 43. And then there are actually 5 different places in which the 7 can go. So we can also have 7, that's not really a comma there. So we can also have 7999997. You don't have to write all these out, but I'll just do it for this one. 99799 and 99979. So we've got 5 possibilities using the digits 4 9s and 1 7. Okay, so now we need to think about if there's any other ways of getting the digit sum of 43. So we know we can't do it with 5 9s. With 4 9s, we're going to have a 7 to get a digit sum of 43. So it might be a good idea now to look at 3 9s. So with 3 9s, just try and make sure that's not looking like 39s. With 3 9s, we know that 9 plus 9 plus 9 is 27. So the other 2 digits have to sum to give us 43 minus 27 is 15. Okay, so if you think about how we can do that, and I've just got that sum wrong, haven't I? Because this is actually 16. We'll try that again. 43 minus 27 equals 16. We're not allowed to use any more 9s because we've said 3 9s. So this is going to have to be 2 8s. Okay, so we know we've got the digits 99988. And we want to work out how many ways we can arrange these. So if we consider having 5 blocks, we've got 5 options for where to place the first 8. So we've got 5 ways we could put the first 8 in. Once we've put an 8 in, then we have 4 options to put the next 8. So there's 5 times 4 ways to place your 2 8s, and then the rest will be filled with 9s. Now, those of you who are quick on the ball will spot that that gives me 20. And I want to show that there are 15 5-digit numbers. So 20 looks a bit dodgy. However, using this method, we've actually double counted, putting an 8 in this point, and then an 8 in that place, or putting an 8 here, and then an 8 here. So we need to divide this by 2. So that's 5 times 4 over 2 ways of placing the 8s. So that gives us 10 ways of arranging 9, 9, 9, 8, 8. And we've said before, we've got 5 ways of arranging 9, 9, 9, 9, 7. So altogether, that gives me 15 ways. So the first part of the question is trying to lead you relatively gently into the ideas. It's told you the answer that you're aiming for, and it's not too big a number. You might expect that the second part is going to be slightly harder, and you'll be correct. Okay, so for the second part, we've got a much lower digit sum. So it's a good idea to be incredibly systematic here. And we'll start by looking at 9s again. So 5 lots of 9s gives us a digit sum of 45. So that's not going to work. 4 9s. 4 times 9 is 36. So the last digit is going to have to be, last digit is going to have to be 3. So we've got 9, 9, 9, 9, 3. And there are 5 different places where the 3 can go. So this is going to give me 5 ways. Okay, so now we need to think about 3 9s. Now we know that 3 times 9 is 27. We want a digit sum of 39. So hopefully I can do 39 minus 27 and not make a mistake this time. So the last 2 have to sum to give you 12. Now there's more than one option now for this. So to sum to 12, this could be a 6 and a 6. That has a sum of 12. It could be a 5 and a 7. That also has a sum of 12. It could be a 4 and an 8. What it can't be is 3 and 9, because we've already talked about that possibility in the 4 9s version. So these are the different options. So if we consider 9, 9, 9, 6, 6, that's the same idea that we had before with the 3 9s and the 2 8s. There are 5 ways of placing the first 6, 4 ways of placing the second 6, but to stop the double counting, we need to divide by 2. So that gives us 10 ways. 4, 9, 9, 9, 5, 7. We don't need to worry about the double counting. There are 5 different places in which you can put the digit 5. There are then 4 places in which you can put the digit 7. But in this case, if we put a 5 first and a 7 second, that is going to be different to if you put the 7 first and then the 5 second. So we don't need to divide by 2 because these are actually different cases. So for this one, we're going to get just 5 times 4. So that's 20 ways. And similarly for 9, 9, 9, 4, 8, we're going to get 5 times 4 equals 20 ways. Okay, so far so good. So now let's look at 2 9s. Okay, so 2 times 9 is 18. So the other 3 have to sum to 39 minus 18, which I think is 21. So that could give me 3 7s. How else could I sum to 21? Well, I could make one of those 7s equal to an 8, which then means the next 7 has to go down. I can't go to more than an 8, because if I go to a 9, then I'd have 3 9s, which is the case we've already done just beforehand. So I can't go to 8. How else can I get 27? So we've looked at 3 7s and 1 7. I could have I can't have two sevens because the third would have to be a 7. So the only case to look at now is no 7s. Now we've got to have something that is bigger than 7 because 3 6s adds to 18. So I think we've got to have 2 8s, which adds to 16, and a 5. And I don't think there's any more options, because if we tried taking this 5 any lower, one of these 8s would have to turn into a 9, and we can't have that because we need to keep it to 2 9s. So I think that's all the options there. So if we consider 9, 9, 7, 7, 7, I'm going to consider placing the 9s this time because there's fewer of them. So there's 5 ways to place the first 9, 4 ways to place the second 9, and then they're both 9, so we divide by 2 to get rid of our double counting. So that's 10 ways. If we have 9, 9, 6, 7, 8, okay, I'm going to consider placing the 6, 7, and 8 first. So I've got 5 places to put the 6. I've got 4 places I can then put the 7. I've got 3 places to put the 8. Nothing has been duplicated because it was a 6, a 7, and 8, so I don't need to divide. So that gives me 5 times 4, which is 20 times 3, which is 60 ways. There are different methods you can use for this. I'm just using one way of counting. And then we've got 9, 9, 5, 8, 8. So I'm going to place the 5 first. There are 5 places you can put the 5. Then I'm going to place an 8 and another 8. So 4 ways to place the first 8, 3 ways to place the second 8. We need to divide by 2 because placing the 2 8s, you need to get rid of the double counting. So an 8 first and an 8 second is the same as an 8 second and an 8 first. So that gives me 5 times 6, which is 30. Right, we're hoping now that we're going to actually almost finish because I'm beginning to run out of space. We have looked at 5 9s, which is impossible. We've looked at 4 9s. We've looked at 3 9s. We've looked at 2 9s. So the last case, well, not actually the last case, 1 9. So if you have 1 times 9, then the rest sum to 30. So if we think about it, let's start by taking as many 8s as we can. So in a similar way to starting at 5 9s. So I could have 3 8s and then a 6 to give me a sum of 30 with these ones. Okay, so the number of ways of doing this, there are 5 places I can put the 9. There are 4 places I can put the 6, and then the 8s fill in. So 5 times 4 equals 20. I can take one of those 8s down to a 7, and then this 6 will come up to a 7. So I could also have 9, 8, 8, 7, 7. And from that point, if I want to try and reduce any, something's either going to have to increase to a 9, which would then become a 2 9 case that we've already thought about, or something will have to increase to an 8, and then we're back to where we started. So this is the last way we can do it with 1 9. So the number of ways you can do it here, if we consider placing the 9s and the 8s, well, this actually, if you look at these numbers here, these are exactly the same format as this one here. We've got 2 pairs of the same number, the 8s and the 7s. That's the same as the 9s and the 8s there, and one separate one. So in the same way, that's going to be 30 ways. In exactly the same way as that. Okay, the last thing we need to think about is no 9s. Okay, so if you have no 9s, the biggest digit sum you can get is 5 8s, which is 40. That's going to be too big. So the only way of doing it is 8, 8, 8, 8 gives me 32 and a 7. And in exactly the same way as this one up here, that's 5 ways. And then there's no others. So it really helps be very systematic as you're going through. Start with the maximum number of 9s, reduce them, and at every stage, you're making sure you're not repeating cases that you found beforehand. We haven't quite finished the question because we actually need to do some adding. And I am just going to circle all the numbers of ways we found. So that gives me 50 there. This gives me 100. This gives me 50. And then we've got another 5 here. So we've got 100 plus 50 plus 50. That makes 200 plus 5 plus 5. So the final answer is 210. However, it must be stressed that if you're doing this question and you just wrote down the answer 210 with no working, you wouldn't get the marks. You need to see the justification that you have found all the ways and that you have shown that there aren't any other ways as well. Right, thank you very much.